Welcome back, students. We'll be learning the second part of glycolysis. We'll be starting from fructose 1,6 bisphosphate. In the previous class, we had learned how fructose 1,6 bisphosphate is formed for the next steps. In this video, we will know the fate of this into pyruvate. We will know the details of these steps, why is it happening, how is it happening, but mostly you will have to rote learn some of them. Can you see I have written this as a flow chart? Why have I written as a flow chart? Because this compound, this 6 carbon compound, is splitting into 2 3 carbon sugars. One is dihydroxyacetone phosphate, the other is glyceraldehyde 3-phosphate. You can remember it by ALD. ALD means alada in Bengali, alag in Hindi. Although it actually means something about aldose sugar, aldehyde group, you can use this as a mnemonic. The thing is, you don't need to remember all these enzymes names. You can remember this one, but you do not need to know the enzyme names of this. But I have written them so that you can use them as a mnemonic to know what is happening in that step in case it ever came as question. Like I said in the previous video, enzymes are like one-word answers for the functions they perform. They help us remember what the step is doing, what is happening in this step. Now that we have converted these the 6 carbon sugar into 3 carbon, these are 2, this is 1, this is 1. You can see this sign. Acha, I've not said one thing in the previous video. Can you guess what is it? I have not explained about this kind of sign. This kind of sign means the reaction is reversible. Means there is no fixed reactant or product. It depends on which is more, which is less. Means this compound can be easily converted to this can be easily converted to this. But in case of reversible steps, like representing for this conversion, this is irreversible, which means you need a separate enzyme altogether to make this step backward, to take this step backward. In glycolysis, there are 3 steps which are irreversible. I will talk about them later. Do not focus on the reversible thing for now, although you can note it down if you want to remember it. Like I said before, triose phosphate isomerase. What does it suggest? You can write in the comments if you want, but I'm still explaining. Triose means 3 carbon sugar, phosphate means a 3 carbon sugar which has phosphate group. Isomerase means there are 2 triose phosphate compounds which are being interchanged in structure, which are going from one form to the other using this enzyme. Now, if this dihab is converted to this GPA, glyceraldehyde 3-phosphate, aren't we getting 2 glyceraldehyde 3-phosphate? See, this fructose 1,6 bisphosphate is splitting into glyceraldehyde 3-phosphate. Fine. It is also splitting into dihab, and this is getting converted to glyceraldehyde, meaning there is another glyceraldehyde being added to the reaction for 1 glucose. 1 glucose is giving 2 GPA, that means, which means whatever steps we have from now on, all will be 2 times of it. We'll have 2 molecules of each of them. You don't need to remember these enzyme names, okay? But I'm writing so that you can remember what is happening in this step. Here, we are getting another phosphate group, See, there is a phosphate in the third position in glyceraldehyde, and in the next step we have one in the one carbon two in the first carbon as well. Where are we getting the phosphate from? From this phosphoric acid. And we to form this glycerate. See, this is glyceraldehyde and this is glycerate, which means it's kind of the anion form of carboxylic acid. You know about carboxylic acid or carboxylate? No. If you study in 11, you won't be able to know about it unless you get to class 12. So I'm not going to much detail, but this group represents COOH and this one has CHO. So you can see this has more oxygen, which means this is getting oxidized to this, dehydrogenated to this, which means we are requiring a dehydrogenase enzyme. For that, we are using NAD+. It is an oxidizing agent. It is an oxidizing agent, but it is not oxygen, which is why we are using which is why the enzyme name is dehydrogenase. This NAD+ is oxidizing this compound into this, but itself is getting reduced into NADH. Why is this happening? Because this NADH will further go and do oxidative phosphorylation and form ATP, which we are not discussing here, but just for your knowledge, one NADH gives 3 ATP. One NADH gives 3 ATP. So we get extra ATP, right? From a now we are getting this molecule. Now we have invested so much ATP in the previous phase. We need to get back more, right? You have studied in your junior classes that glycolysis generates 2 ATP as energy. But we had used 2 ATP before, which means to get a net amount of 2 ATP, we need to gain 4 ATPs. I'm not explaining the calculation right now, but if you keep this knowledge in mind, you will be able to understand it better when I explain this calculation. Just for now, you remember this, the substrate names. 1,3-bisphosphoglycerate is being converted to 3-phosphoglycerate, which means the carbon from this position is being removed. Sorry, not carbon. The phosphate from this position is being removed, and that phosphate is being used to add an extra phosphate group in ADP. Means ADP plus phosphate equals to ATP. Since there are 2 molecules of this one, we are getting 2 ATP. Okay, you can forget it right now. Now we have been converted to this. See this inside. Phosphoglyceromutase. Mutase is kind of like isomerase. It's doing isomerization only. We are doing nothing, but there is a phosphate group in the third position. We are just shifting the phosphate to second position. That's why it's forming an isomer. It's changing in structure, but the molecular formula is same. Okay, no problem. Now, why are we doing this? Mainly because of energy reason. We need the form from where phosphate would be released, and from this breaking of bond we'll get maximum amount of energy so that we can generate a lot of ATP. And the phosphate group here does not release much energy when being broken, when being separated from glycerate group. So we have shifted to this second position so that we can get more energy. convert this compound into PEP, phosphoenol pyruvate, we need to release what? You can remember by enolase. You have drank Eno, right? Eno, you have seen the advertisement. If you have indigestion, you just put some Eno in water and then you drink it. So if you see this word Eno in this glycolysis, you will remember that water is releasing, water is coming out. So even if you forget so that's why I'm telling you, remember the enzyme names so that you can remember what is exactly happening in this step. An H2 molecule, a water molecule, is going out and this is being converted to phosphoenol pyruvate. This step is what? It's dehydrating. It's dehydrating, right? From this PEP is the real story beginning. Because from here, pyruvate is formed. Like I said before, this is an irreversible step. This is an irreversible step. In this step, we are getting so much energy that we are able to generate an ATP. Remember, we need a sufficient amount of ATP, a sufficient amount of energy to generate ATP, because one ATP releases a huge amount of energy. So to create it, we also need a huge amount of energy. So this ATP is converted to ATP and pyruvate, and then pyruvate goes to its fate in mitochondria. It goes to mitochondria now. Hope you're able to see it. Yes. It goes to mitochondria for oxidative decarboxylation, Krebs cycle, the fate. Have you noted it down? Okay. Now, we'll be explaining this calculation. Please focus on here. See this ATP. See this one. What is being created? I'm writing in red so you can understand it. For one of this compound, for 1,1,3-bisphosphoglycerate, we're getting 1 ATP. For two of such similar compound, we'll be getting 2 ATP. Then from here, we're also getting ATP. This phosphoenol pyruvate. One phosphoenol pyruvate is creating one pyruvate, which means 2 phosphoenol pyruvate will create 2 pyruvate, which means here 2 ATP is formed. So these are 2 ATP, this is 2 ATP. So total we are getting 4 ATP. Now think about what I've said before. You have studied in junior classes that in glycolysis we get only 2 ATP. Why is it? We actually get 4 ATP, but we had already invested 2 ATP in the previous step. That's why we are now getting 2 net ATP, because 4 minus 2 is 2. Now, what else should I teach you? Yes, you might get confused that how is it getting 2? So I am repeating this again. We are talking about what happens from one glucose. This entire glycolysis that I am explaining is based on what happens from one molecule of glucose. From one molecule of glucose, 3 carbon sugar is formed. when it is being split. From one glucose, fructose is formed. From this, fructose is split into dihab and GPA. One GPA goes to this glycolysis, and then when this dihydroxyacetone phosphate gets converted to another GPA, that GPA also goes into glycolysis path, and we are getting both of this from one glucose. This one glucose, we can say that indirectly is creating these two compounds. If you still have any doubt regarding this calculation, you can DM me. Take a nice screenshot of these notes. Okay, so this is it. I hope you're able to understand it. I know these are a lot of details, but I recommend that you make a flow chart of it, make a chart of it, hang it in your wall, and look it every day. Just remember what I've told you about what happens in which step, and just look at it every day. You will passively understand it, meaning you will every day, if you look at it, it will get engraved in your head, and you don't have to put much effort into learning glycolysis. Okay, so I hope you have a nice day. Goodbye.